So to set context, I'm going to tell a quick story. And the story takes place in New Jersey. All of New York, all of New Jersey is buzzing. Emotions are running wild. With a young, talented roster, a defensive-minded head coach, and finally an elite quarterback, the New York Jets fans finally have a reason to believe that this could be their year, their moment. In 22 years removed from the tragic events of 9/11, Aaron Rodgers is decked out in all white. He has stars and stripes in hands and comes running onto the field. Meadowlands, MetLife Stadium erupts. Jets, 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 Jets. It's electric. You don't even have to be a Jets fan to get pumped up about it. The scene is awesome. But then, just 10 plays in, the unthinkable happens. All those hopes, all those dreams come to an end. Now, I'm Phil Martin, VP of Emerging Technology at Fox, and I'll let Niall introduce himself.
Hey folks, nice to meet you all. My name is Niall Turbitt. I'm a data scientist on our professional services team at Databricks, and we've been working closely with Phil's team over at Fox Sports to accomplish some of the stuff that we're going to walk through today.
Cool. Thanks, Niall. So, last year, Fox Sports achieved 266 billion minutes viewed, our best year ever. We made up 34 of the top 100 viewed programs. So the probability that you saw a piece of our content last year is extremely high. And looking to continue our success this year, we have a tremendous slate ahead that kicks off this week with the UEFA Euro Championships, followed by MLB's tribute to the Negro Leagues, postseason, and World Series, a beefy college football slate that features Michigan versus Texas, Alabama, Wisconsin, the game, Ohio State, and Michigan. And of course, the #1 viewed program in America, America's Game of the Week, will be commentated on by none other than the GOAT himself, Tom Brady. All these roads lead to New Orleans for the Super Bowl on Fox. Now, to achieve this level of success, you have to be customer focused. And our customer is the fan. And creativity and ingenuity is in Fox Sports DNA and has been that way since our inaugural season in 1994 when we debuted the scorebug. Now imagine that. You tune into a game and you don't even know what the score or how much time is remaining. Or in 1998 when we developed the technology that powers the first down marker. And then even as late, developing the Megalodon camera that creates a cinematic view of the game. All this and more has transformed the fan experience and set new industry standards. And as new technology and capabilities emerge, we are rapidly building and iterating to continuously elevate that fan experience. Now, if you can't tell by now, I'm a bit of a passionate sports fan. I truly believe sports is a unique and in a class of its own when it comes to content. And why is that? Well, think about it. For 20 plus straight weeks, 40 million plus Americans plan their Sundays around the NFL slate. Well, why is that? It's because every emotion known can be experienced during live sports. Joy, happiness, fear, frustration, and if you're a part of Cowboys Nation like me, depression. Now, these emotions attach us to moments. So let's talk about moments. Moments are a point in time. They're instant. And live sports is filled with moments, hundreds. In MLB, there's over 300 pitches thrown. NFL, 100 snaps taken per game. 175 plus field goals are attempted in the NBA. Live sports is riddled with moments, and moments create and define your fandom. Your moments tell your fandom. Now, whether that's the highs, like UVA being the first ever #1 seed to lose to a 16 seed, just to bounce back the following year and seize that moment to become national champions. Or the lows, when Des Bryant in 2014 goes up and makes a miraculous catch to put his team in position to win the game late in the fourth quarter in Green Bay, just to have that moment ripped away. Or the bigs, like Jorge Soler smashing a home run, one of the longest home runs in World Series history. Everyone at home and watching knew from that moment on that the game and the series was over. And the smalls, like the first time you ever saw Caitlin Clark hit a step-back three In the grander scheme of things, it was just in a regular season game, and it was insignificant. But nonetheless, that moment was captivating. Again, moments matter. It doesn't matter whether you were in attendance, saw it on TV, or social media. They create and define your fandom. They dictate how we watch, how we talk, how we bet. And we at Fox are obsessed with capturing and contextualizing these moments with data. We are committed to expanding and transforming our technology and data stacks so that we could dive deeper into these moments, creating more immersive and personalized experiences than ever before. To date, we have captured over 150 years of sports data. We are generating millions of insights in real time, and we have developed dozens of proprietary machine learning models so that we can continuously push these boundaries. Now, let's talk about the transformative impact that GenAI has had in accelerating and elevating our offerings on Databricks. In the past, efforts to elevate the fan experience could take upwards of months, but now, with the power of GenAI, we can achieve those same high-caliber results within weeks. Not only that, we maintain flexibility by having complete ownership of our data and our models while optimizing both cost and outcomes. Through the instructional fine-tuning of an open-source large language model, we were able to collapse thousands of scripts into a single efficient model. In the past, we had tried alternative ML techniques like back translation, where we took those insights, translated to German, back to English. However, that solution was unreliable. We've streamlined a complex vision and language orchestration process into just a few steps to allow us to infer segments, topics, and entities. Through this understanding, we're able to respond and deliver to fans and bring them closer to the action and discussion than ever before. Now, all this couldn't be achieved without deep contextual understanding of both our content and our sports data. And with this powerful platform, we're able to continuously innovate and elevate so that we can ensure that every moment isn't just a memory, but a deeply personal journey. Thank you. Now Niall's going to dive deeper into segment topics and takes. Thanks.
Cheers, Phil. Cool, so the technical part. How did we go about solving this? So firstly, let's just frame the actual problem statement that we're looking at. We're looking at Fox Sports studio programming, which runs continuously for 8 hours a day. So through that, what we have are audio transcriptions, which provide a wealth of data for LLMs. The question then stands, how can we unlock the individual fandom that Phil was talking about from this data? Is it possible that we can identify specific clips by topics, by entities, an entity being, think of the likes of a player, a team, a league, or takes. And takes in this context are kind of standout takes from a presenter on a given show. So this might be something like, Patrick Mahomes is not going to win the NFL MVP this year. On top of that then, how do we make all of this searchable? So from a process standpoint, what we're looking at is that shows are transcribed, as I was saying, in real time. And what that looks like is something like this. You have these chunks of transcripts coming in, and think of this as like 30-second chunks coming in each time. Given these incoming transcripts, can we extract segments, topics, takes, and entities? Furthermore, can we then provide a semantic layer over all of this data that we subsequently then index? So think of a query like Mahomes MVP. We want to be able to search against takes, topics, and segments. And this might be something like, Mahomes will not win the MVP this year, a topic, who is the biggest threat to Mahomes, or a longer segment, such as NFL MVP discussion. So if we think about what a high-level workflow would look like for this, firstly, you have your transcripts coming in, and for those incoming transcripts, you saw that we had those kind of 30-second chunks coming in. We want to be able to identify a longer segment. Following this then, we want to do segment processing. So for that extended segment, we want to extract summaries. We want to be able to extract topics, takes, and the entities. So who are the players, the teams, the leagues that we're spoken about. For the semantic search layer over the top of that, we then want to index all of this data. We want to have the semantic search layer on top of that. So we can distill this down into two key components. The first is this continuous streaming pipeline where we're doing real-time indexing. And this is the incoming transcripts, so those 30-second chunks, where we're doing then segment identification. And think of this as we want to be able to understand when is the start of a segment and the end of the segment. Given this kind of concatenation of those little segment chunks, can we then put this into a processing pipeline whereby we give summarization, we extract topics, we extract those takes, what was the kind of notable standout take from that given segment, and then furthermore, who are the entities being discussed. All of this, then index it into a vector database to then provide the ability to then query over the top of that. And this will be our query layer on top of that. So where before you have this streaming of transcripts and indexing out to a vector database, we then have this asynchronous component that allows us to semantically search over all of those properties that we're extracting. From an implementation standpoint, we can spell out what this architecture looks like. Sorry, it's just jumping on a bit. Okay, our base infrastructure then. We're looking at this through the lens of a single Databricks workspace in Fox's environment. And in terms of the kind of key components that we're using here, we're built on top of the lakehouse. And for that, we're using Unity Catalog. And Unity Catalog is going to be the kind of foundation through which we're managing and governing our data and AI assets. From an infrastructure AI component then, we're using Mosaic AI model serving, as well as vector search. And I'll run through the exact specifics of how we're using those. So the first piece, that's segment identification. So remember those 30-second chunks of transcripts continuously streaming in during show programming. We're using Databricks Autoloader to continuously listen to the underlying storage so that we know each time a new transcript is dropped into that. That's then written out and appended to a transcripts delta table. We then have this pipeline, this segment identification pipeline. And really what that's trying to do is understand when is the start and end of a given segment. And to be able to do this in a continuous fashion, what we're using is Spark structured streaming. So that allows us to continuously run that pipeline and to continuously stream in those chunks of transcripts. And using model serving, what we're doing is sending calls to an LLM endpoint that allows us to detect when is the start and end of a given segment. For each new segment that we identify, we're then persisting that out to a separate delta table, which in this diagram is the segments table. The next step then, this segment processing, is the multi-step process where we want to take a segment, we want to summarize it, we want to extract takes, topics, and identify the entities being discussed in that specific segment. And all through this, what we're doing is similarly using a foundation model API to send out calls to an LLM endpoint. With that then, we're then indexing all of these properties that we're extracting. These are being indexed into 3 separate vector indexes, and those are the segments index, the topics index, and the takes index. And what we're doing with this is we're using Databricks, we're using Mosaic AI vector search. And what that allows us to do is have an embedding endpoint. And for each of those properties that we're extracting, we are embedding it, so creating a vector representation of each of those different aspects that we're extracting. And we are then indexing those to those 3 separate indexes. And all of this then is providing us with the ability to have that semantic layer over all of that information that we're extracting out of that just continuous stream of programming. So end to end here, what we're looking at is those transcripts coming in. We are segment identification to identify what a given segment is, and then indexing everything out the other side. So let's pivot over to the actual query layer. So how do we then asynchronously provide the ability to do semantic search over all of this information that we're indexing? If you see, focus on just that middle component of the query layer endpoint. Think of this as logic that allows us to take a query, and for that given query, to search against all of that information that we've indexed across those 3 different indexes. And how we do this is that we have an MLflow model in which we essentially define that logic to take an incoming query and then to parallelize how we do that queries against those 3 different indexes. And all this allows us to do is to have a REST API that allows us to do this in real time. So what are some notable challenges that we stumbled across here that I think are kind of interesting to call out? So for the first part, that segment identification, it's a non-trivial task to continuously stream that in and identify when is the start and end of a segment. Furthermore, it's kind of subjective. When does that segment start and end? And what we also need to do is we need to maintain state as we do this. So what this means is that each one of those little chunks of transcripts that we're ingesting, we need to understand in the middle of that, is that the end of the segment or is this part of an existing segment? So all the while what you're having to do is maintain state within that pipeline. And once you identify that segment, you're then appending that to the existing table. And something interesting that we were able to find out here is that with stateful processing and Spark streaming, we can consistently make those API calls to that foundation API. Meanwhile, we're persisting out those that process data to that existing Delta table. On the evaluation side of things, so this is very much extensible to all GenAI applications, is that there's often a lack of ground truth. If you think about how you would summarize a given segment, there can be multiple right answers. And so what this kind of made challenging was that without correct right answers, you often have to involve humans in the process, at least to build out an initial evaluation set. On the other side of the coin, specific for this, we also have compounding errors. So if we incorrectly identify a segment, this kind of trickles down in that we're then incorrectly identifying topics and incorrectly identifying takes as well. So something that was important for us here is building the infrastructure and the processes as well to get human evaluation, to build out that muscle for being able to quickly gather that feedback, but then act on it and really speed up that iteration loop. Lastly, in many of the components, what we're aiming to do is extract JSON output from LLMs. And something, I mean, if a lot of you have worked with LLMs, it can be tricky to kind of coerce into generating structured output. And something that we utilized here was a validation post-processing step. You want this ultimately to be pretty lightweight if you're doing this in a kind of real-time continuous fashion. And what we found worked really well here was Pydantic, just in terms of having that lightweight layer where we could enforce that schema and validate outputs. So some key takeaways then. And I think this is kind of generally extensible to a lot of GenAI applications is firstly LLM selection. So I think there's often the temptation to reach for the largest, most capable model possible to address your core issues. And one thing I would probably urge folks to take away is to start small, see if a smaller model can achieve what you're looking to do. In many cases, what you're doing is you're trying to solve a very specific task. And if a smaller model can achieve that task, then ultimately you're reducing the cost, number one, but also the latency there as well. So start small, figure out quickly, does that model address or solve your task, and work your way up to more capable models as you need. Mosaic AI model serving made this really simple for us in the sense that we were able to quickly switch in and out of different models through both foundation model APIs, which allowed us to stand up open source models, right the way through to external models as well, so that we could experiment with proprietary models. On the fine-tuning side of things, so as Phil was alluding to, there is a wealth of data within Fox Sports through all of the hosts of transcripts and sports news articles that we can also think about fine-tuning models as well, in that we can domain adapt models to inherit the kind of tonality of how Fox Sports wants kind of LLMs to generate text, right the way through to instruction fine-tuning. So that's specifically targeting tasks. Mosaic AI model training allowed us to easily do this. We can do either continued pre-training in terms of domain adapting a model and both then instruction fine-tuning as well to direct the model and guide it to a specific task. So lastly, I also spoke about vector search, Mosaic AI vector search, something that was was really nice here is that we were able to use the delta sync index component of vector search. And effectively what this does is that as we are streaming and continuously processing that data, processing the segments, extracting all of the information, and writing out that information to those source delta tables, we could then set up this delta sync, which continuously sync those updates to our indexes. So just in terms of the business value, so what does this all unlock? Really what this does is laying down the foundation for content discovery. So this is enabling real-time annotation. So as those transcripts roll in, can we do that extraction of segments and all of the various attributes that we're trying to extract from those? Furthermore, given that we're indexing all of this information, you have this flow out that we have the ability to search across all of these different attributes. So we can dive into a specific topic, we can search over segments themselves, and we can search by specific entities that appear in all of these attributes that we're extracting out. So it's really exciting work in terms of how we can extract all of this information, continuously stream it in, and it really does lay down the foundation for what we can do in terms of unlocking that business value with Fox Sports. So thank you very much for listening. Very excited to work with Phil and the team, and much work going forward that we're very excited about. Cool. Thank you.